How does it work?
Wow, I'm up there. I can't believe it.
What does it do? What makes it really tick? Follow me, Rick Ross, in my journey on how it all makes sense.
This is Rick Ross from ARICKROSSPRODUCTION. And man, I got a surprise for y'all. While I was walking, I saw this nice little company called NextFab. Let's see what's beyond the horizon of Philadelphia. And it looks like these guys are up on their technology. Let's go and check them out.
Coded DNA.
Oh man, you got me.
What's in the box? Tell me what's in the box. Please tell me what's in the box.
I'll tell you in a little bit.
For more information, I gotta go to the website.
Exactly.
Come on, tell me what's in the box. What's in the box?
Hi, my name is Maximilian Maksutovic, and I am the software lead for Biomeme. Biomeme, we turn your smartphone into a DNA analysis lab, enabling anyone to discover the biological world around them. So the idea is you're sick. You go to the doctor. You don't know what's wrong with you. They will do a blood test, a saliva test, send it out to a lab, and then 2 days, 2 weeks later, you'll find out what's wrong. So how the lab does it is this technology called PCR, which stands for polymerase chain reaction. And the idea is that DNA is really small and it's hard to see. So a way to be able to see it easier is by making copies of it, making billions of copies of it. And so how it works is that you have DNA. It's double-stranded. Heat that DNA to 95 Celsius. That double strand becomes 2 single strands, kind of floating like this. Basically, then you take some chemistry and you cool and put them into these little tubes that we have right here. And this is exactly how they do it at the lab when you go to the doctor. And so inside these is a bunch of different little enzymes and other chemicals that you need. So you heat them up to 95, you separate the DNA, and then you cool it down to 60 degrees. Once it hits 60, if there's some bad bug in that sample, the enzymes will attach to that single strand and then make a copy. And so from that 2 single strands you had, now you have 4. Next time you do it, you'll have 16, and then 32, and then up to 1 billion times. So within half an hour, you can find out if you have the flu, if you have malaria, dengue, anything. Ebola, exactly. So,
Oh man.
yeah, so that's the essence, that's the underlying technology that's inside this. And so the problem is that these PCR machines that are available now, they're locked away in big expensive labs and in universities. And so what we're trying to do is shrink it down, make it real cheap, add your smartphone to it, and therefore anyone can go around in this mobile package and look for E. coli in their water, look for salmonella in their tomatoes, see if their child has the flu, or basically anything that has DNA. And we're discovering there's all these incredible technologies coming out that require DNA to be looked at. In the 1970s, to use a computer, you had to be a PhD or spend a lot of money. And people said, oh no, the layperson will never use computers. Well, if you look at today, everyone's using computers. They're all, supercomputers are in their pockets now. And we believe that the same thing will be for biology and for DNA in the next few years. And so that's what we're working on, is trying to enable anyone to discover the biological world around them. California, so we're all transplants to Philly, but really falling in love with this great city. And ever since then, it's just been a lot of hard work and building new prototypes and new versions of the app and And this box, which is what we hope that you'll buy at CVS one day to do your own testing at home. And so let me show you a little bit of the app. Because we're trying to make this as cheap to produce as possible, so that we can deploy thousands of these devices all over the world. So what you can imagine is because we're using the smartphone, we have an easy way to transmit data, right? Cellular networks are all over the world. And therefore, you can actually do real-time disease monitoring around the world. Open up Google Earth, and you'll see little pins drop every time there's a positive result for malaria, every time there's a positive result for Ebola. You could see that in real time, thanks to this device. And then, and what's so great about the flexibility of PCR or DNA is that it's not just strictly, you're looking at pathogenic infections. You could do things where you can do something called a sniff test. And what this does, you can see, does your genome create folic acid? Some people have a mutation in their gene that doesn't allow them to make folic acid, and they actually need a supplement. With this, we could see that. You could see if you have the risk gene and see if you're predisposed to doing risky behavior. There's basically, that's the beauty of DNA and biology. It's a new frontier. And there's all this incredible technology that's coming around it. And the thing that we're lacking is easy to use tools that anyone can use. And that's what we're trying to do.
Expect that. But wow. Philly, we gotta look around, keep our head, look up and see what's going on. I mean, there's so much technology right in the city alone. I mean, it's all there. And all we gotta do is just reach out and just take advantage of it. I mean, as many times as I've been skateboarding around the city, I never really thought to really come in here and really investigate on what's going on here.
Is that these PCR machines that are available now, they're locked away in big expensive labs and in universities. And so what we're trying to do is shrink it down, make it real cheap, add your smartphone to it, and therefore anyone can go around in this mobile package and look for E. coli in their water, look for salmonella in their tomatoes, see if their child has the flu, or basically anything that has DNA. And we're discovering there's all these incredible technologies coming out that require DNA to be looked at. In the 1970s, to use a computer, you had to be a PhD or spend a lot of money. And people said, oh, no, the layperson will never use computers. Well, if you look at today, everyone's using computers. Supercomputers are in their pockets now. And we believe that the same thing will be for biology and for DNA in the next few years. And so that's what we're working on, is trying to enable anyone to discover the biological world around them.